Alright, bienvenidos mis amigos. Welcome back, my friends. Okay, today this is part two of the Emmy award-winning mini-series Solving Equations. Alright, the objectives of this second part is for you to solve equations with variables on both sides and solve equations containing grouping symbols. Okay, some of this is a little more advanced than what you're ready for particularly, but I want to give you a kind of an exposure to this to show it to you. We're going to talk about distribution, and we're basically skipping over the easy multi-steps and going straight to the hard multi-steps so that uh, my philosophy is this: if you can do the hard, the easy is easy, even easier, I guess. Alright, so let's just go ahead and get started. Let's say we have this problem here. Solve 3x plus 2 equals 4x minus 1. Okay, there's a couple things we want to do here. We need to get the variables on one side of the equation. It doesn't matter which variable you move. Try to move the one that will keep your variable positive. So notice here we have an x on this side of the equals and an x on this side of the equals. So what we need to do is we need to move them together. Well, we want to keep them positive. So the way you keep them positive is by moving the smallest variable. So in this case, the smallest variable is 3x. So I need to move this 3x over here with the 4. Leave the 4x over there, but move 3x to the 4. Move the smallest one every time you get a chance. So in order to solve this, the first thing we're going to do is we're going to draw what I call is the river. The river helps us organize our work, and I am going to require you to draw this river, especially at the very beginning when we're learning to solve equations. So here's our river. Just keeps our work in line and neat and organized. Again, organization is key to success. Okay, so in order for me to move the 3x from the left side of the equation over here, in order to get it over here, I have to still think opposite like I did in the one-step equations. So this is a positive 3x. I'm going to move this entire value. I'm not worried about getting this number away from the x right now because I have multiple x's, so I need to get them together before I start worrying about taking the numbers off. So in order to move this 3x, since it's positive because there's no sign in front of it, I've got to subtract 3x from both sides. So I'm going to subtract 3x like that. This is going to eliminate the 3x on the left hand side, leaving me with 2. And again, when I simplify, it leaves me with 2 equals x minus 1. Because again, over here, these subtract 3x minus 3x is 0. That leaves me with 2 down here. 4 minus 3 is 1x, but we don't have to write the 1. And that's why we have that. And then negative 1 just comes down because we didn't do anything to it. Now, you should be looking at a very simple one-step equation. The only number that keeps my x from being by itself is the negative 1. So I want to move that negative 1 by adding it to both sides, because opposite of negative is positive, or the opposite of subtract is add. So I'm going to add 1 to both sides of the equation. What that'll do is that will eliminate these numbers right here, and then it leaves me with x. 2 plus 1 is 3. So when I simplify, it's 3 equals x, or x equals 3. That's the same thing. If I want to check my answer, I just plug 3 back into everywhere there's an x, and I solve. So instead of writing 3x now, I write 3 times 3 plus 2 equals 4 times 3 minus 1. If they're right, they balance. 9 plus 2 equals 12 minus 1 as I simplify. 3 times 3 is 9 plus 2. 4 times 3 is 12 minus 1. 9 plus 2 is 11. 12 minus 1 is 11. They balance, so they're right. This is where order of operations really kicks in, and it's important that we understand our order of operations. Alright, let's look at another example. Let's solve 8y minus 9 equals negative 3y plus 2. Again, you'll notice I have a y here and a y here. I've got to get them together. Okay, I got to move the smallest y. The smallest y is going to be the negative one. Anytime you have a negative and a positive y, the smallest y will always be the negative one. So the first thing I want to do is draw the river. Sorry. Get these y's together. So I'm going to add 3y to both sides because the opposite of negative 3 is a positive 3. That's going to cancel out the 3 y's on the right hand side. When I simplify, that's going to leave me with 8y plus 3y. 8 plus 3 is 11y. Bring down the negative 9 because I haven't done anything with it, so 11y minus 9 equals 2. All that's left over there is a positive 2. Okay, now I've got to start peeling away the things from y. Now notice, The goal here is to get this y by itself. So I've got to start peeling these numbers off. But I want to start with the number that's furthest away from the y, that's separated from the y. Notice 11 is close to the y because it's multiplying. This negative 9 is furthest away from the y. So I'm going to start with this negative 9 first. So I'm going to peel it away. The way I'm going to peel it away is, again, negative 9. How do I get rid of it? The opposite of negative 9 is to add 9. So I'm going to add 9 to both sides because what you do to one side, you must do to the other. So a negative 9 plus 9 cancels each other out, leaving you only with 11y. And then, of course, 2 plus 9 is 11. So when I simplify, I have 11y equals 11. Now, again, what does 11y mean? If you remember from our last video, the first part, 11y means the same thing as 11 times y. The opposite of multiply is divide, because our key factor here is to do the opposite. So if I take 11 and I divide it by both sides, I get 1 because the 11's cancel out. Y, when I simplify, y equals 1. Again, I want to check my answer. I plug it back in. 8 times 1 is 8 minus 9 gives me a negative 1. Negative 3 times 1 is negative 3 plus 2 is with negative 1. So it does check out. I know I'm going pretty quick through this, but feel free to pause and kind of synthesize this work and make sure you understand. Okay? And again, if you ever have any questions after watching a video, come see me in the morning at tutoring at 8:25. Okay? This slide is kind of messed up, so we can go ahead and skip that. But if you want to work through that 3 minus 4x equals 18 plus x, you can. Obviously, you see on the screen there the answer is negative 3. Okay? So let's go ahead and solve this one here. Okay? Again, the first thing we want to do is draw the river. Now notice, we have the variables on the same side this time. So if the variables are on the same side this time, all you have to do is combine like terms. Like terms are those terms that look the same. If a term has an x, if it's a number and an x, that is not the same. For example, 7x is not the same as 4. Those are what you call unlike terms. But 7x and negative 3x are like terms because they're the same. Okay? Because they both have x's. That means they're like terms. Okay, so we need to combine like terms. So 7x minus 3x is 4x. So now I have 4x equals 4. Now I want to get that 4 away from my x. Remember, what does 4x mean? That's right, 4 times x. So divide both sides by 4. And that leaves me with 1. Simplifying, you have 1x equals 1, or x equals 1. If I want to solve, again, I want to check my answer, just plug it back in. Wherever there's an x, plug in 1. So let's see, 7 times 1 is 7, minus 3 times 1 is 3, so 7 minus 3 is 4. So 4 equals 4. That does check out. Okay, so here's where we're going to introduce distribution. Again, we're going to have another lesson about distribution later, but I want to give you a quick preview of distribution. So let's solve this one, negative 7. What this says is negative 7 times x minus 3 equals negative 7. Okay, first thing we want to do is draw the river. The next thing we want to do is distribute. Distribute means take this 7 and multiply it by x, and take this 7 and multiply it by 3. Whenever you distribute, distributing is what you do in order to get rid of the parentheses. Distributing is distributing everything, the one thing on the outside touching the parentheses to everything on the inside of the parentheses. So when I distribute, I have negative 7 times x is negative 7x, and negative 7 times 3 is positive 21 equals negative 7. Notice, I did not distribute this negative 7 all the way across to this negative 7. You only distribute the number to the numbers inside the parentheses. So negative 7 times x equals negative 7x. Negative 7 times negative 3 equals positive 21. And then I just bring down the negative 7 on the other side. Okay, again, I want to get across the river. I got to get everything away from the x across the river to the other side. A way to look at this is say, okay, I got to pay the toll. In order to pay the toll, I've got to do the opposite here. 21 is the furthest thing away from my x. It's a positive 21. The opposite is a subtract 21 from both sides, because what you do to one side, you must do to the other. So when I subtract 21 from both sides, when I simplify, that'll leave me with negative negative 7x equals negative 28. Again, if this is confusing you, that's why you go back to that integer rule book that we already created, or use your calculator. Putting this in the calculator right will show you negative 7 minus 21 is negative 28. Same signs, keep the sign, add the numbers together. Okay? Now I have negative 7x equals negative 28, or again, negative 7 times x equals negative 28. I've got to get rid of that negative 7, so I do the opposite of multiply and divide both sides by negative 7. Negative 7s cancel out, and negative 28 divided by a negative 7. When you divide, the two negatives cancel out, leaving you with a positive 4. Okay, so we end up with x equals 4. Alright, check our answers, just plug it back in. When I plug it back in, I can do 4 minus 3, order of operations is 1, negative 7 times 1 is negative 7. Both sides balance, so my answer must be right. Alright, so what is the value of x if 3x plus 4 equals 3 times x plus 4 equals 2 times x minus 1. Go ahead and pause the video, work this one out by yourself, see if you can do it. Again, just challenge yourself. If you don't think you can do it, just give yourself a try. The only one person that's going to know you did it or got it wrong is you. Okay? So pause the video and see if you got it right, because I'm going to show you the answer in 3, 2, 1. That's right, the answer is negative 14. So give yourself a hand if you got the answer right. If you got it wrong, don't worry. Remember, failing is the first attempt in learning. Alright, we've got some nasty fractions here. We've got a whole bunch of fractions. So let's take a look. Let's go ahead and take this piece by piece. First thing we want to do is draw the river, as always. Next thing we want to do is we want to clear the fraction. Instead of working with all these fractions, let's clear the fraction. So what we do to clear the fraction is multiply each term by the lowest common denominator. Okay? So let's take a look what that means. The LCD is 8. They all have 8 in common. 2 can go into 8, 8 can go into 8, and 4 can go into 8. So you got to multiply everything by 8. And when you do that, these 8s will cancel out, leaving you with 3. 8 times 1 is 8, divided by 4 is negative 2. So now you have 3 minus 2x equals 8 times 1 is 8, divided by 2 is 4x, minus 8 times 3 is 24, divided by 4 is 6. So when I simplify this, I'm going to end up with 3 minus 2x equals 4x minus 6. So it looked pretty bad at the beginning, but multiplying everything by 8, okay, clears out my fraction. You have to multiply everything by the LCD. You cannot just multiply piece by piece. Even if you have the whole number, you would have had to multiply that by 8. Okay. Again, I need to get my x's together, because notice how I have two x's here, one on this side and one on this side of the river. I need to put them on the same side of the river. In order to go across the river, you've got to change something. Okay, so I got to move the smallest x. The smallest x is always the negative one. So the opposite of minus 2x is to add 2x to both sides. So I'm going to add 2x to both sides. 2x's are going to cancel out. When I simplify, leaving me with 3 equals 4 plus 2x is 6 minus 6. So 3 equals 6x minus 6. Okay, over here, this minus 6 is the furthest away from my x, so I've got to get it to the other side, so I need to add 6 to both sides, leaving me with 6x equals 9. Okay, 6 I got to get rid of by the x. I've got to divide both sides by 6. So dividing both sides by 6 leaves me with 9 6 equals x. Simplify, 9 6 ends up being 3 halves or 1.5. You can check your answer and it comes out. Alright. In this case here, this is the last one. I got about 30 seconds to finish this up, and then this is it. In this case, I have x's on both sides. I'm going to draw the river. X is on both sides. They're both the same x. So just pick one to move. So let's subtract 2x from both sides. When I subtract 2x from both sides, what happens? You simplify, there's no more x left. And then you have a statement that's 5 equals negative 3. Since it's not true, then your answer is no solutions. So that's pretty much it. There's another special case we can go through later, but that's it.